Hello and welcome back to the channel. In this video I'll be going over speed as part of your proportionality topic for your GCSE exams. So let's start by looking at the formula for speed. So the formula for speed is simply speed is equal to distance over time. This is a key formula that you're going to need to learn for your maths GCSE and for your physics GCSE as well. And it's quite simple, so you're better off learning it by heart. You're not given this formula in the exam. And you can write this out in a formula triangle as well. B would go at the top because it is the product of the speed and the time, which would go at the bottom. Okay, let's look at some questions then. So the first question says, a man runs 3 kilometers in 15 minutes. Calculate the man's speed in kilometers per hour. So the first thing that you need to pay attention to here is that the time is given in minutes and we want our answer in kilometers per hour. So the first thing we're going to have to do is convert the 15 minutes to hours. So 15 minutes is equal to 15/60ths of an hour is equal to a quarter of an hour. Now we can work out our speed. So speed is equal to distance over time. So our distance here is 3 and our time is a quarter. So if I write this out a bit more nicely, it's 3 divided by a quarter, which is 3 times 4, which gives us a final answer of 12 kilometers per hour. Okay. The next question says, work out how long it takes a woman walking at 1.5 kilometers per hour to cover 300 meters. Give your answer in minutes. So feel free to pause the video now and have a go. And we'll go over the question now. So our distance here is given in meters, but our speed is given in kilometers per hour. And then the question says give your answer in minutes. So we're obviously not going to be working with minutes in the question itself because the units for speed are either kilometers per hour or meters per second. So we're not going to be using minutes for our working out. We'll see what we get to at the end and then we'll convert that to minutes. But for the time being, let's convert the meters into kilometers and then try to work it out that way. So to go from meters to kilometers, you have to divide by 1,000. So 300 meters is equal to 300 over 1,000 kilometers equals 3/10 of a kilometer. Now we can rearrange our formula for speed. So speed equals distance over time, and we want our time here. So we're going to rearrange for time. So distance equals speed times time, and so time is equal to distance divided by speed. Now we can put our values in. So the time would be equal to 3/10 divided by 1.5 kilometers per hour is equal to 15/10 as our speed here. And because we're dividing, we're going to take the reciprocal of our speed here. So it's going to be 3/10 times by 10/15. Tens cancel out. We get 3/15, which gives us a final answer of 1/5. So our answer here is 1/5 of an hour, but the question says give your final answer in minutes. So in order to convert that into minutes, I'm going to multiply 1/5 by 60 to get a final answer of 12 minutes. Okay, let's take a look at the next point then. So the next part I want to talk about is conversions because this is quite a big thing you're going to have to deal with and be expected to know for your exams. So first aspect of conversions we're going to look at is distance conversions. So you're going to be expected to know how to convert from meters to kilometers, and it's very simple really. There are 1,000 meters in 1 kilometer. So to go from meters to kilometers, you're going to have to divide by 1,000. To go from kilometers to miles, you're going to have to divide by 1.6, because there are 1.6 miles in one. No, there are 1.6 kilometers, sorry, in 1 mile. Time conversions then. So to go from an hour to a minute is 60 minutes in an hour, so you're going to multiply by 60. To go from a minute to a second, you're going to have to multiply by 60 again. And then to go from an hour to a second, well, you're going from an hour to a minute and then from a minute to a second, so it's going to be 60 squared, which gives us 3,600. So to go from an hour to a second, you're multiplying by 3,600. The speed conversion that I want to talk about is kilometers per hour to meters per second. Now, this is one that comes up quite a lot, but they don't expect you to know what the conversion rate is. They expect you to work out in the exam. So if you can nail this down, it's going to be quite beneficial for you in the exam, because you can just work it out. You know what it is off the top of your head, instead of having to spend around 3 minutes they give you to work this out. So I think you'd be better off just learning this right now. So let's do meters per second to kilometers per hour, because I think that's going to be simpler than working out kilometers per hour to meters per second. So to go from meters per second to kilometers per hour, let's just break it up and work out the top part first and then the bottom part. So to go from meters to kilometers, we said we'd divide by 1,000, and to go from seconds to hours, we said we'd divide by 3,600. So from meters per second to kilometers per hour, we're doing 1 over 1,000, because we're dividing by 1,000, and we're dividing that by 1 over 3,600. This gives us 1 over 1,000 times by 3,600 over 1, which gives us 3,600 over 1,000, and a final conversion rate of 3.6. So in 1 meters per second, there are 3.6 kilometers per hour. Again, you'll be better off learning this off the top of your head, because it can save you a lot of time in the exam, and the time in the exam is going to be quite precious. Okay, let's take a look at a question which involves these conversion rates then. So the question says a spacecraft travels 5.76 times 10 to the 5 kilometers in a day. Work out the aircraft's speed in meters per second and give your answer to two significant figures. If you think that you can tackle this question on your own, then feel free to pause the video and have a go. This is a calculated question, but I will go over the question right now. So the first thing we're going to look at is converting this day into hours. So 1 day contains 24 hours. Let's then work out the speed in kilometers per hour, and then we can convert it into meters per second using our conversion rate that we just found. So speed in kilometers per hour would be 5.76 times 10 to the 5, that's our distance, divided by 24. Put that into our calculator. We get an answer of 24,000 kilometers per hour. If we convert that then into meters per second, well, that's going to be 24,000 divided by 3.6, which gives us a final answer of 6,000 700 meters per second to two significant figures. Okay, let's look at the final point then. So the final thing I want to go over in relation to speed is bounds. That is upper bounds and lower bounds. So in the exam, you may be asked to work out the upper bound of a speed or the lower bound of a speed, and there's really two key formulas that you need to be on the lookout for. This is in general for any upper bound or lower bound, really, but we'll go over it for speed right now. So the upper bound for speed, which is the highest possible value of a speed that has been rounded, or its values have been rounded. So the upper bound of the speed would be equal to the upper bound of the distance divided by the lower bound of the time, because this would give you the highest possible value for the speed, because we're using the highest possible value in the numerator but the lowest possible value in the denominator. And to work out the lower bound of the speed, we just do the opposite of what we just did. So it'd be lower bound of the distance over the upper bound of the time to work out the lowest possible value for the speed. Okay, let's look at one final question then that involves bounds. So the question says a car travels at 187 kilometers to three significant figures in 3 hours to the nearest 100 seconds. Using bounds, work out an approximate value for the car's average speed in kilometers per hour. Okay. So there are a couple of ways that we can go about doing this question, but I think we'll go about it by converting the speed into meters per second and then using our conversion rate to turn it back into kilometers per hour. So let's start by doing that then. 187, use a black pen. 187 kilometers, first of all, is 187,000 meters. 3 hours in seconds is 3 times 3,600 is 10,800 seconds. Therefore, our upper and lower bounds for our distance and time are going to be these. So upper bound for the distance, lower bound for the distance, upper bound for the time, lower bound for the time. So the upper bound for the distance here is to three significant figures. So 700 here. So our upper bound for the distance would be 187,500 meters. And our lower bound for the distance would be 186,500 meters, because 186,500 is the lowest possible value that would round up to 187,000, and 187,500 is the highest value. Well, it's not the highest value, but it is the value at which the values will no longer round to 187,000. So we take that as our upper bound. So the upper bound for the time then would be to the nearest 100 seconds at the 8th position here. So the upper bound would be 10,850 seconds, and lower bound would be 10,750 seconds. We can work out our upper bounds and lower bounds for the speed then. So the upper bound for the speed we said was the upper bound for the distance divided by the lower bound for the time. Put that here, so 187,500 divided by the lower bound of the time, it's 10,750. And then we work this out in our calculators and write out the full calculator display. And you'll see why later when we look at the second part of the question where it says work out an appropriate value for the car's average speed. So 187,500 divided by 10,750 gives us an answer of 17, 17.44186,045. And then we can work out the lower bound of the speed then, which would be the lower bound of the distance divided by the upper bound of the time. That would be 886,500 divided by 10,850. If we put that into our calculators, we get an answer of 17.18894. Okay. When it says using bounds, work out an appropriate value for anything, you have to look at the upper bound that you've got and the lower bound that you've got, and then you have to see where they round to the same value at which decimal places. So here, if you look, for example, at 2 decimal places, well, that doesn't work out, does it? Because 17.44 is not the same as 17.19, which we'd get for the lower bound of the speed. And if we look at 1 decimal place, we get 17.4 and 17.2, still not quite the same. But if we look at two significant figures, well, we get 17 and 17. And that is the first rounding that we'd get the same value for both the upper bound and the lower bound. So here, our final answer would be 17 kilometers per hour. Sorry, 17 meters per second, because that is the value at which both the upper bound and the lower bound round to, and then we can multiply that, or divide that, sorry. We'd multiply that by 3.6 to get our final answer here. If you put that into the calculator, we'd get 61.2 kilometers per hour as our final answer. And that is the end of the video. If you found the video helpful, please do like and subscribe. Leave a comment if you have any questions. I will try my best to get back to you as soon as possible. And yeah, that's it.